Okay, beta, the recording of the meeting is now on. So let's continue with our session. Last lecture I had done site solving method with you. We done the 5 methods. Purpose, long bar thrown, intercept, x meridian, and polar. So first of all, any doubts or query coming to your mind related to site solving, beta?
सर मून के केस में जो सॉरी मून में नहीं, एक मिनट से
सर ये एक क्वेश्चन में साउथ ऑफ ऑब्जर्वर था, लैटिट्यूड दिया नहीं था, तो साउथ ऑफ ऑब्जर्वर, तो उसमें जो हमारा MZD है वो नॉर्थ हो जाएगा, साउथ हो जाएगा, तो उसमें कंफ्यूजन था।
Right. So Marpa's question में if they do not give us latitude, sometimes they would tell us in which direction the body is. So once we know in which direction the body is, we know the azimuth of the body. So we know the altitude is named same as azimuth and MZD is named opposite to it. So in this case, if the body is bearing south, true altitude would be south and MZD would be north.
सर एक बार रिपीट कर देंगे सर दोबारा।
ओके बेटा, देखो नॉर्मली हम इन क्वेश्चंस में जो शॉर्टकट मेथड यूज करते हैं उसमें हम MZD की नेमिंग करते हैं. हाउ डू वी डू द नेमिंग? MZD is named opposite to altitude. And how do we name the altitude? In whichever direction the body is, the altitude is named same. So if the body is north of us, altitude is named north. If body is south of us, altitude is named south. Now, most of the questions, they do not tell us the azimuth of the body straight away. So we have to find it using the observer's latitude and the body's declination. For that, we had discussed that shortcut method. Okay. Now, in some questions, it is possible. They may make it simple for you by simply telling you what is the azimuth of the body. If you know the azimuth straight away, no need of making a rough diagram, nothing. Whatever is the azimuth, the true altitude should be named in the same direction. And MZD should be named opposite to it. Okay, beta, did you get it?
Yeah, okay, sir.
Okay. Any more doubt, query coming, beta?
सर ये पोलैरिस के क्वेश्चन में जो निकाल रहे हैं मेलमन एक्स से पीछे रेफर करके,
किसमें बेटा? योर वॉइस इज ब्रेकिंग ऑफ, कैन यू रिपीट?
पोलैरिस क्वेश्चन सर, पोलैरिस
राइट.
उसमें हम ट्रू एजिमुथ जो लेते हैं A0, A1, A2, उसके बाद ट्रू एजिमुथ एलमन एक्स से पीछे से,
राइट.
तो वो सर लैटिट्यूड के रेफरेंस में लिया हुआ है, तो वो जो लैटिट्यूड लिया है वो डीआर लैट जो क्वेश्चन में दिया है वो लिया है या ऑब्जर्व्ड लैटिट्यूड जो हम निकाल रहे हैं सॉल्यूशन में उससे लिया है?
बेटा किसी से भी
कौन
लेते
सा
हैं,
लैटिट्यूड लेके सेम ही आएगा,
क्योंकि
छोटा सा डिफरेंस है.
because difference between DR and observed lat is not going to be much. और हमारे टेबल में लैटिट्यूड की वैल्यूज हैं, they are far apart.
ठीक है सर.
Okay. However, अगर कभी confusion हो भी जाए, it is better to take the observed lat in that case.
Correct sir. Okay, thank you sir.
Okay. Okay. और बेटा any more doubts in any of the methods? Okay. So बेटा फिर आगे चलें. Shall we move on to the next topic?
Yes sir.
Okay, all right. So let me first familiarize you about कि हमारा जो next topic है ये अब क्या होने वाला है. See, till now we have worked out these astronomical sites: Marpas, Long Bicron, Intercept, X Meridian, Polaris. अब इनमें बेटा हमने अलग अलग मेथड के साथ, डिपेंडिंग अपॉन व्हाट इज द सिचुएशन, व्हाट इज द सिनेरियो, हमने अलग अलग मेथड्स को यूज किया. एंड एवरी वन ऑफ दीज मेथड्स, इट बेसिकली गिव्स अस ए पोजीशन लाइन. सो हर एक मेथड ने हमें एक पोजीशन लाइन दे दी. दिस पोजीशन लाइन कैन बी प्लॉटेड ऑन द चार्ट एंड we can have the PL marked on the chart and we can see where the ship's position is. It should be somewhere on that line. But you see, position line in itself is not much helpful to us. What we are interested in is the actual position of the ship. Position line can run in safe waters. Position line can pass from land also. Position line may be running from dangerous waters also, shallow waters, shoal patches, over wrecks, navigational dangers, everywhere. So what we are interested in actually is the position of the ship. Now, how does this PL help us to achieve or attain the position of the ship? For obtaining the position, we need at least 2 position lines. 2 position line हमें at least चाहिए from 2 different bodies. तो अगर हमें ये 2 पोजीशन लाइन मिल जाएं and we plot them on the chart, when we plot them, these position lines will be intersecting at any point, and that point where the position lines intersect will be our position. So that is the ultimate aim of doing this PL calculation. So one site in itself is not sufficient for us. We need 2 sites now, 2 sites. Because if you want to obtain 2 PLs, you need to work out 2 different sites. Now, if these sites are worked at the same time, it is known as a simultaneous observation. If the sites are worked out at different times, why we are working out at different times? It could be possible that at a particular time only one body is available to you. For example, at daytime, you only have sun, which is visible to you. There is no other celestial body usually in the sky. So in that case, we can take a sight of the sun. Then after taking that sight, since there is no other body which is available to us, we can wait for some time. And after some time, we can take another sight. So we will get 2 different position lines from these 2 observations. And then we can combine them. We will have to bring them in on one time by transferring a PL. So this method of calculating or finding out 2 PLs, then plotting them on the chart and finding the vessel's position is our next topic. It is known as graphical combination of sites. It is also known as staggered or simultaneous plots. If the 2 observations are taken at the same time, it is known as a simultaneous observation. That means both have been taken at the same time. And if there is a time interval between the 2 observations, one is taken after some time, you wait and take another observation, then it is known as a staggered observation. So we also call it by the name of simultaneous and staggered observation. So we will now see how do we plot these PLs and how do we attain a fix from them. Now this method, graphical combination of sites or plotting of sites or staggered and simultaneous plotting, is very similar to Chartwrok. So in Chartwrok also we work out with PLs and position circles. And in Chartwrok also we plot these PLs and find out the point where they are intersecting. That is our position, that is our fix. There are many methods in Chartwrok in terrestrial navigation where we can obtain PLs very easily. You take the bearing of a lighthouse, immediately gives you a PL on the chart. So in these plots, most of the time, celestial observations are given to you, but it is also sometimes possible that they may involve a terrestrial position line also. They may give you one celestial PL, that a sun site was taken and a PL was obtained, and they may along with it give you a terrestrial PL. They would say at the same time the bearing of this particular lighthouse was so and so, the lighthouse was in this latitude and longitude, and you will be required to combine them. So it could be two celestial PLs which are combined. It could be a celestial PL or a terrestrial PL, or it is also possible they may give you two position circles. One position circle, then another position circle, and wherever they intersect will be your position. So all these combinations are possible in these questions. Now, as I told you, these questions are very, very similar to what we do in Chartwrok. However, there is one major difference. This difference is a little impractical. We do not do it in real life, but unfortunately in our paper, it comes in this way. The difference is that in Chartwrok, you have the chart available to you. The position lines have to be plotted on the chart. But in these questions, the plotting or the PL which is done is not done on the chart. The positions are not present on the chart. So what you have to do is, you have to make a small replica of the chart on your answer sheet and then do these plottings. So we will see how do we make the replica of the chart, and we will see how do we plot them and obtain our position. So this was the introduction to the topic which we are going to do. I will open up the presentation now, and we will go ahead doing these plotting concepts. ओके इसका जो बेसिक कॉन्सेप्ट है that we have just now discussed, so let's see that concept in the presentation also. The same things which we have discussed will be repeated here. So we have all worked astronomical sites using different celestial bodies, sun, stars, planets, and moon. And with all these observations, we have calculated position lines. However, the ultimate aim of the navigator is to calculate or fix the position of the ship. A position line only signifies that the vessel's position lies somewhere on that PL, but it could be anywhere on the PL. In fact, when we mark these two arrows on the ends of the PL, let's say this is the PL which you are having, we mark these arrows on the end of PL. They signify that it is not that the vessel's position is going to be only within this zone. It can be anywhere on the PL extended. So that is what a PL signifies. Now, if we have at the minimum two such position lines, then wherever they intersect will be our position. So this is what is plotting of sites. For two PLs, we need to work out two astronomical sites. If both sites are taken at the same time, it is known as a simultaneous observation. Now, for a simultaneous observation, see, you will have to have two sextants available to you on the ship. There should be two persons who should be standby, and there should be two celestial bodies. then only a simultaneous observation can be taken. Even if there is a gap of 1 minute between the observations, it is not called as a simultaneous observation. It is called as a staggered observation. Simultaneous observation means that you have taken the observation at the same instant. If sites are taken at different times, they have to be transferred to a single time, allowing for the vessel's speed and course. So if you have taken 2 sites and the sites are staggered sites, then we have to transfer the PL and bring them to one single time. Now, most of the time, I would say 99% of the time, we are interested in our latest position. So we always transfer the old PL or the previous PL to the most recent position line. But sometime in some of the questions, it is possible. You may have to transfer the position line backward also. It all depends upon what is given in the question. So this is known as a staggered observation. How do we transfer the position line? The transfer of position line is done exactly in the same way as we transferred PL in Chartwrok. Okay, so let me just tell you. Now, when you are transferring a PL, let's say we have this position line, and it was, let us say 0900 PL. You can consider it for any method. Let's say long by crone. If it was long by crone, you have the observed lat, DR lat, the observed longitude, and this is where the PL is passing. So next site, let us say, is taken at 1100 hours. And at 1100 hours, you have the second PL available to you. Now, if you want to transfer the PL, you need to know what is the course and speed which you have made good between this time. So 0900 to 1100, what is the course and speed or course and distance which you have made good? Okay. Now, PL is always transferred using course made good or course over ground and speed made good or speed over ground. We never use the CTS, course steered and engine speed, for transferring. We always use the course made good and the speed made good. And how do we transfer it? You pick up any single point on the PL. The best point would be whose latitude and longitude is known to you. So this point is the best point. Then you apply your course and distance. Let us say the vessel was steering 135 and the speed was 12 knots. So in 2 hours, 24 miles is what the vessel is going to cover. So you cut that distance and you get a new reference point. Now you draw a line parallel to the initial PL and you have the transferred PL on your plot or chart. Transferred PL is represented by double arrows. So mark it with double arrows on both the sides. And now you see the transferred PL is also brought to 1100 time. We have applied the course and distance for 2 hours. So it has been transferred to 1100. Now for 1100, wherever these 2 PLs cut, that is our 1106. So PL is transferred using this method. Now, if you want to transfer a position circle, we have done this in Chartwrok also. When we are transferring a position circle, the position circle is transferred by applying the run or the course made good and distance made good on its center. So you apply your course made good on the center and you get a new reference point. And from this reference point, you draw the new position circle. So this will be the transferred position circle. The position circle is transferred by applying the run on the center of the circle. A position line is transferred by applying the run on any position on the PL. Preferably recommended if you have the latitude and longitude of a position, then that would be the best point to transfer the PL.
सर ये आपने 900 आवर्स से जो लाइन खींची वो कोर्स मेड गुड था,
राइट?
तो सर ये 9 बजे वहां पे थी पोजीशन, 11 बजे वहां पर आ गई, तो फिर वो कोर्स मेड गुड, तो अगर हम 9 to 11 को ज्वाइन करेंगे तो कोर्स मेड गुड तो चेंज हो गया सर।
ओके, दैट्स राइट बेटा। वो कोर्स मेड गुड क्यों चेंज हुआ? कोर्स मेड गुड एक्चुअली चेंज नहीं हुआ। कोर्स मेड गुड तब चेंज होता अगर, लेट मी चेंज द कलर, ये पोजीशन हमारी फिक्स होती। ये पोजीशन फिक्स तो नहीं है बेटा, दिस इज जस्ट ए रेफरेंस पोजीशन टू ड्रॉ द पीएल। फिक्स तो कहीं भी हो सकती है इस पीएल पे।
ओके ओके सर, ये फिक्स 9 वाली फिक्स नहीं है, 11 वाली फिक्स है। ओके
राइट, 9 o'clock पे तो सिर्फ हमारे पास एक रेफरेंस पॉइंट है जिससे पीएल ड्रॉ करनी है। अब जब हमारे पास 1100 फिक्स आ गई है तो हम 900 फिक्स भी निकाल सकते हैं। कैसे? आप यही कोर्स मेड गुड को अपनी फिक्स पे रिवर्स डायरेक्शन में लगा
देंगे। राइट सर,
राइट। So wherever it cuts your initial PL, that would be the 9 o'clock fix beta. Okay. Okay. So I'm erasing the ink on the slide now. Okay. So as I told you, coming to the last point now, the difference between plotting in celestial navigation and plotting on the chart is, now on the chart it is very, very easy. You have all the positions, the grid of latitude and longitude available to you on the chart. So you can simply plot the PLs, you can draw the courses, you have a parallel ruler, you have a compass rule, everything is. But here in these cell nav plotting questions, they will not give you these questions on the chart. If this was on the chart, this would be easy for us. It would be just another simple Chartwrok question. But they tell us to do it on our answer sheet. So we have to construct a small part of the chart on our answer sheet and then plot these. So this procedure of constructing a small part of the Mercator chart and plotting 2 or more PLs to get the vessel's position is known as plotting of sites. अब बेटा जब हम मर्केटर चार्ट का एक छोटा सा पार्ट अपनी आंसर शीट पे बनाते हैं तो यहाँ पे भी कुछ डाउट्स हमारे माइंड में आएंगे। जो ये मर्केटर चार्ट है इसमें दोनों एक्सिस पे, जो ये वर्टिकल एक्सिस देख रहे हो आप और जो हॉरिजॉन्टल एक्सिस है, दोनों एक्सिस पे डिफरेंट स्केल्स होते हैं। यू हैव द लैटिट्यूड स्केल एंड यू हैव द लॉन्जिट्यूड स्केल। अब अगर हमें इसी चार्ट को अपनी आंसर शीट पे बनाना है तो दो स्केल के साथ इसे बनाना तो बहुत कॉम्प्लिकेट हो जाएगा। बना सकते हैं, ऐसा नहीं है कि बना नहीं सकते हैं। हमने प्रोजेक्शन वाले टॉपिक में जो क्वेश्चंस किए थे उनमें हमने इस चार्ट को बनाया भी था, उसमें हमने लैटिट्यूड और लॉन्जिट्यूड दोनों ही लगाए थे। बट इन प्लॉटिंग क्वेश्चंस में हम इसे दोनों स्केल्स के साथ नहीं बनाते, अदरवाइज द क्वेश्चन वुड बिकम वेरी वेरी लेंथी। Beta, just give me 1 minute. There is an important call. Just 1 minute, I'll be back. Okay, beta, sorry for the interruption. I had to send one question paper, so that's done now. Let's resume. Okay. So we were discussing about the Mercator chart. I told you that the Mercator chart is actually based on two scales, latitude scale and longitude scale. But for the purpose of plotting, we do not make both the scales in the chart because it will make the question little complicated and very, very lengthy to be completed in 20 minutes. It would be a difficult task. In fact, construction of a Mercator chart comes as a full-fledged another question, 20 marks, 25 marks question. So we make a very simple Mercator chart for our plot. Now, if you want to make a simple chart and use only one scale out of these two, beta, can you tell me which scale will you prefer? Will you prefer the latitude scale or you prefer the longitude scale?
So longitude scale में
ओके अब यहाँ पे एक डिफरेंस है बेटा. कंस्ट्रक्शन जब हम कर रहे थे चार्ट की तो हमने लॉन्जिट्यूड स्केल को प्रेफर किया. रीजन फॉर दैट वाज दैट लॉन्जिट्यूड स्केल इज ए फिक्स्ड यूनिट, फिक्स्ड स्केल. बट प्लॉटिंग के टाइम पे हम लॉन्जिट्यूड स्केल को नहीं लेते हैं, हम लोग लैटिट्यूड स्केल को लेते हैं. द रीजन इज कि प्लॉटिंग के टाइम पे हमें डिस्टेंसेस को अपने प्लॉट में शो करना पड़ता है. लाइक आई जस्ट नाउ शोड यू, if you want to transfer APL, you have to put your course and distance. You have to cut the distance. Now, distance is measured in units of latitude scale. 1 minute of latitude is equal to 1 nautical mile. So, for the purpose of plotting, we take only the latitude scale. We do not take the longitude scale at all. So the chart is constructed using only the latitude scale, and on that chart we plot our position lines. So let me tell you how do we plot this chart. Let us first discuss some salient points, features of the Mercator chart. Now on the Mercator chart, all the meridians are parallel to each other, and we know 1 nautical mile is equal to 1 minute of DLAT. We also know the distances are measured in nautical miles, and the latitude scale is the scale for measuring distances. If you measure a north-south distance in nautical miles, that is equal to the DLAT between two places. Let us say you have 2 points here on the Mercator chart. You measure the north-south distance between them. Immediately gives you the DLAT between them. And if you measure the east-west distance between these 2 points, what will that give us, beta?
Departure, sir.
Very good. Just remember this. It will always give you departure, never de-long. So east-west distance between two places measured along the latitude scale will give you departure in nautical mile. It would have been de-long if we would have used the longitude scale. अगर हमने longitude scale use किया होता तो ये de-long बन जाती साइड ईस्ट-वेस्ट डिस्टेंस वाली, और जो नॉर्थ-साउथ डिस्टेंस वाली साइड है वो DMP बन जाती. पर हमने longitude scale use नहीं किया है. So the north-south side would be the DLAT, and the east-west side would be, or east-west distance between 2 points would be the departure. So हमारे प्लॉट में बेटा हमने हमेशा ये याद रखना है कि जब भी कभी हम ईस्ट-वेस्ट डिस्टेंस अपने प्लॉट में डालेंगे, we will only put the departure, never the de-long, and vice versa. कभी भी हम ये ईस्ट-वेस्ट डिस्टेंस अगर अपने प्लॉट से पिकअप करेंगे, it will always be the departure, never the de-long. अगर हमें डी लॉन्ग चाहिए तो हमें डिपार्चर टू डी लॉन्ग उसे कन्वर्ट करना पड़ेगा यूजिंग द पैरेलल सेलिंग फॉर्मूला।
तो मतलब प्लेन एंड पैरेलल सेलिंग याद रखनी है सर, यहाँ मर्केटर सेलिंग छोड़ देनी है।
एग्जैक्टली बेटा, यहाँ पे मर्केटर सेलिंग बिल्कुल यूज नहीं होगी, यहाँ पे प्लेन एंड पैरेलल सेलिंग ही यूज होगी। ओके, सो प्लेन एंड पैरेलल सेलिंग के फॉर्मूले भी हमें रिवाइज करने हैं। ओके, departure, sorry, dlat is equal to distance cos course, departure is equal to distance sin course, and the third formula was tangent course is equal to departure upon dlat. So ये फॉर्मूले आपने वापस रिवाइज कर लेने हैं बिफोर यू गो इनटू द प्लॉटिंग क्वेश्चन, क्योंकि प्लॉटिंग में ये सारे के सारे फॉर्मूले प्लेन एंड पैरेलल सेलिंग यूज होगी। As I told you, east-west distance, if we measure it along the longitude scale, is the d long between them. But in this plot which we are making, we do not have the longitude scale, so we cannot have the d long picked up straight from the plot. If we want d long, we will have to find it using the parallel sailing formula. Departure is equal to d long into cos of m lat. ओके
सर एक बार पिछले वाली स्लाइड करेंगे सर, वो साइलेंट पॉइंट वाली।
ये वाली बेटा?
हाँ सर, 2 मिनट सर।
ओके, लेट मी erase the ink on this. Yeah. Done beta, shall we proceed ahead?
Yes sir, thank you.
Okay. Okay, so this is the parallel sailing formula. This you already have with you. Now coming to plotting. So how we will make this plot on our answer sheet? Chartwrok plotting we are all familiar with. We know how to plot things on the chart. But for this plotting, as I told you, this is a little simplified chart. So let's see some points which will help us when we do our plotting. Plotting can be done on plain paper. Sometime in the MMD, they provide you with a graph paper also. The only advantage there in the graph paper is that you have parallel and perpendicular lines. So it will be easy for you to draw the parallel of latitude and the meridian. That's all. Otherwise, plotting can be done on the graph paper as well as plain paper. Graph paper, if it has an advantage that it provides you with parallel and perpendicular lines, has a disadvantage also. Usually the size of the graph paper is lesser than your answer sheet. So your plot will be slightly smaller. Okay. Now, when you have to make a plot, you will need to select a certain scale. Scale like 1 centimeter is equal to 1 nautical mile or 1 minute of dlat. So some scale like that has to be selected to make the chart or plot on your answer sheet. About 80% of the questions can be solved using this 1-to-1 scale only. Most of the time when the paper setters make these questions, the question is made in such a way that you are able to accommodate the plot using this scale, about 80%. 15 to 20% of the question, you may need to change the scale. So for that, how will you come to know? As you practice these questions, by looking at the data which is given in the question, धीरे धीरे अपने आप आपको ये आइडिया होना शुरू हो जाएगा कि मेरा ये जो प्लॉट है वो आंसर शीट पे आने वाला है और इट इज गोइंग टू स्पिल ओवर. व्हाट डू आई मीन बाय दिस इज, लेट अस से आपने प्लॉटिंग शुरू की, एक पीएल आपने ड्रॉ कर दी यहाँ पे ऐसे, दिस वाज 1 पीएल, एंड सेकेंड PL जो है ये आपने ड्रॉ की. द सेकेंड PL वाज लेट अस से लाइक दिस. अब जब आपने दोनों PLs को एक्सटेंड किया तो पता चला कि आपकी जो पोजीशन है ये तो MMD के टेबल पे आ गई है. So now there's no way you can staple it with your answer sheet. So in this case, if the plot is going out of your answer sheet, you have to increase the scale. If you make it 1 centimeter equal to 2 nautical mile, immediately the size of the diagram would become half. So you will comfortably have it on your answer sheet. So 1 centimeter is equal to 2 miles. In some questions, it is possible that the question may involve very large distances. It can go up to the range of 50 or 60 miles also. 50 to 60 nautical miles. Now to accommodate these distances, then it is possible, or it is possible only if we increase our scale to a substantial value. Now if you want to accommodate about 60 miles on your answer sheet, you will have to go up to a scale of 1:5 or 1:4. Okay, means 1 centimeter is equal to 5 nautical miles. This kind of scale, because answer sheet जो हमारी है बेटा, उसकी जो width है, the width is about 15 centimeters. That is the width which is available to us. अगर आपने 60 miles का सर्कल वहां पे बनाना है, 60 miles diameter का सर्कल वहां पे बनाना है, तो आपको about 1:5 का स्केल प्रोवाइड करना पड़ेगा. So once you do that, this 15 centimeter will get converted to 75 nautical miles. So कुछ एक क्वेश्चंस हमारे ऐसे होते हैं जिनमें हमें 1:5 तक का स्केल भी लेना पड़ सकता है. Okay, so this was about the scale. Whatever scale you select, it should be clearly mentioned in the plot. So when you make a plot, the scale should be prominently mentioned there. Without the scale, the plot is meaningless actually. As I told you, most convenient scale is 1 centimeter is equal to 1 mile. And if you find that your plot is not getting accommodated in the answer sheet and it is spilling over, you can double it up, 1 centimeter equal to 2 miles. Avoid fractions in scale. Okay, don't be tempted to put the scale as 1:1.5. Okay, avoid fractions. Either you take it 1:1 or you take it 1:2, because with fractions, the probability of making mistakes and error in the plot increases. And when you are solving questions in the exam, that time your mind is under pressure, and this is certainly going to give rise to some error somewhere. Okay, now I told you about transferring of the position line. Now there are two methods with which PL can be transferred. One method I already discussed with you, that you can pick up any point on the PL and apply the course and distance paid good to that point, and whatever point you get, that is the position to draw the transferred position line. So this is known as geometrical method or graphical method or plotting method, because in this method we will be using geometrical tools. We will be using our 360-degree round or D to mark the courses. We will be using compass or scale to mark the distance, and then we will be using parallel ruler or sliding ruler or set square to plot or draw a transferred position line, a parallel line. Now there is another method which is possible to us, with which we can transfer the position line, and that is known as calculation method. So what is that method? Let me show you. Let us say we have a position line like this, morning 9 o'clock, 0900, and let us say the second PL was taken after a long time, let us say at 1700 hours. you see 8 hours of time have passed from the first PL to the second PL, 8 hours. Now, if the vessel is traveling at a speed of 10 knots, the vessel has already covered a distance of 80 miles. Okay, so when you have to apply the run has to be 80 miles. Now, the calculation method which we have, what we do in that method is we pick up this reference point, latitude and longitude, and we apply the course and distance using plane and parallel sailing. We do not plot it on the chart. Okay, we do not plot it. So what we do is we take this position, that is the reference position which is there on the first PL, DR lat and observe long in this case, as our starting position. We take the course and distance which the vessel has steamed, and we apply this course and distance to the initial position using plane and parallel sailing, using those formulas of departure, DLAT, and course. So we calculate what will be our position arrived. So it is not plotted on the chart, but calculated using plane and parallel sailing. Starting position is known to us, course is known to us, distance is known to us. So we straight away calculate our position to draw the transferred PL. Now, once we get that position, we plot that position straight away on our answer sheet. So on our answer sheet, we do not plot the initial position, we plot the final position only, and we straight away draw the transferred PL. This is known as calculation method, because in this method, we have not used any tools to transfer the position line. No pencil, no scale, no sliding roller, parallel ruler, nothing. We have done the entire thing by calculation, by plane and parallel sailing. So these are the two methods which are available to us: geographical method or plotting method, and second is the calculation method. Now, calculation method can be used anywhere. It does not have any restrictions or limitations. It is accurate. Maybe the distance could be half a mile, or distance could be 50 miles or 500 miles. It will be accurate. But the plotting method has a restriction. See, whenever we use our plotting tools, as the distance keeps on becoming bigger and bigger, the error in our plot also keeps on becoming bigger. You see, हमारे scale, parallel ruler, 360 degree round, sliding roller, set square, in सब में error है. The thickness of the pencil which we are using, they all bring error in our plots. So हम इसे ज़्यादा distance के लिए use नहीं करते हैं plotting method को. So what is the distance which we recommend, beyond which it should not be used? The distance for these plotting questions is 10 miles. So if you are transferring a PL and the distance is less than 10 miles, you can use whichever method you like. You like plotting method, it can be used. You like calculation method, it can be used. But if the distance is more than 10 miles, now let us say in this question, the distance has come to the range of 80 miles, it is recommended to use the calculation method. Plotting method or using geometrical tools for this bigger distance should be avoided. One, the error would become appreciable. It cannot be neglected then. And secondly, beta, you see, 80 miles अगर आपको अपनी answer sheet पे plot करना होगा, you have to take a very small scale. So 1:6 या 1:7 का scale आपको लेना पड़ेगा. और ये जितना आप increase करते चले जाओगे, स्केल को जितना आप इंक्रीज करते चले जाओगे, आपके प्लॉट की एक्यूरेसी उतनी ही कम होती चली जाएगी. सो दैट इज व्हाई व्हेन द डिस्टेंस इज मोर देन 10 miles, the geometrical method or graphical method or plotting method to transfer the PL is avoided. So we use plane and parallel sailing instead. Let us erase the ink now and let me show you.
सर क्वेश्चन ज्यादा माइल के आते हैं, 10 से ऊपर माइल के आते हैं?
क्वेश्चन बेटा दोनों तरह के आते हैं, लेस देन 10 भी आते हैं, ग्रेटर देन 10 भी आते हैं। ओके, तो दोनों टाइप के क्वेश्चंस इक्वली with equal frequency they keep on coming. So nothing like that you will have longer distances or short distances. Okay, so this is the meaning of the last line which we just now discussed, that runs in excess of 10 miles should be calculated and should not be plotted. Okay, so this is about the basics of plotting. So we have already finished our first session time. So let's take a break here. Let these points move in your minds a little bit over the break. And then after the break, next session, we will proceed ahead and see how do we do the plotting. Maybe we can take an example. We will take one example question and I'll show you how do we do this plotting. And then we can move on to practicing these plotting questions. So let's take a break now. Let's be back at about 45.